Yeah, hi guys. So today we'll be looking at the fourth chapter of your Sec 3 syllabus. So that will be coordinate geometry. So let's look at the learning objectives. So by the end of today's lecture, you should be able to calculate the gradient given 2 points. You should also be able to find the length of a line segment. And thirdly, you should be able to derive an equation of a straight line. And uh, okay, just give me a moment. Yeah, thirdly, you should be able to derive an equation of a straight line. And the last point is more on application-based problems. So you should be able to solve geometry problems. Okay, so now let's get started. So earlier we have learned the Cartesian plane in your lower set concepts. So what that basically means is being able to plot your points in a plane. So let's say given that you have a point that is, for example, you have a point P, which is called 2 comma 1. So you can plot this in a plane, in a two-dimensional plane. So your vertical axis would be your y-axis and your horizontal axis would be your x-axis. So yeah, let's say this point is 1 and this point is 2. And then when you hyperextend, so this point here will be your point P. Okay, point P 2 comma 1. So this is the basics of plotting. So now let's look at the concept of gradient. So when you have 2 points, two different points. Also, just some things to take note is whenever you show your points, right? Your first point is always your x-axis. And then your second point depicts your y-axis. Okay? Which is why the second point is 1, which corresponds to 1 in your vertical axis, which is also known as your y-axis. Also, do remember to write your origin. Okay, so for gradient, when you have two different points, so let's say you have a point A here and point B here. Okay, then I draw a straight line connecting these 2 points. So let this point be 4 comma 5 and this one be maybe 2 comma 1. Okay, just an example. All right. Yeah. So again, draw the origin. So now I'm asking you to find the gradient of this point. So gradient is basically calculating your slope of the point. So it's essentially your vertical change over your horizontal change. Over your horizontal change. Or also known as your rise over run. Okay. So your this direction is called your rise. Rise, and then this direction is called run. Okay. So yeah, so just the formula for gradient is just y2 minus y1 over x2 minus x1. So now that you know the formula, to calculate the gradient of AB, you just apply this formula. So in this case, your y2 will be 5, y1 will be 1 over x2 will be 4, x1 will be 2. Okay? So you will get 4 over 2, which is equals to 2. In this case, in a case where you swap the y2 and y1, so instead of putting 5 minus 1, you put 1 minus 5 over 2 minus 4, you still get the same answer. You will get minus 4 over minus 2, which gives you 2 as well. So it doesn't matter which one you appoint to be y2 and which one you appoint to be y1. Just make sure that if you let this be x2 comma y2, then this one should be x1 comma y1. You cannot have x1 here and then y1 here, okay? So that will contradict. So just make sure you're consistent. Okay, so I believe that should be simple. Okay, can you guys pause the video here and try out this question? I will go through in a bit. Okay, so again, applying the formula, gradient equals to y2 minus y1 over x2 minus x1. Okay, so you will get 2 over 5. Okay, let's try more questions. Again, pause the video and give it a shot. Okay, so in this case, your gradient is given to be -2. However, your values are in terms of k. So you're told to find the value of k. Alright? So again, it's the same approach, just treat it like a normal problem. So your gradient equals to your y2 minus your y1 over x2, which is k minus 2. So this is given to be -2. Oh yeah, before I carry on, okay, no, I will teach after this. Okay, so once you have this ready, you just need to simplify the equation. 5 minus k is equals to -2 times k minus 2. Then you bring your k over, you get k equals to -3. Okay? So simple. Okay, so before we carry on, just a quick conceptual information. So if your slope is going upwards like this, your gradient is greater than 0. Okay? If your slope is going like this, your gradient is less than 0. Okay? So you have one, two. Okay? Later you will see two more different types of straight lines. Okay, so now it's time for practice. So again, do pause the video and try out these questions. Um, I will do one of it, the other one I'll go through during lesson. Okay. So PQR have a coordinate. So they gave you the coordinates. If the gradient of PQ is equals to the gradient of PR, find the value of K. Okay. Okay, so before we even carry on, what does it mean when they say that the gradients are equal? Okay. What does that mean? So gradient actually gives you the slope, right? So if they say that the gradient is equal, that means the two lines are parallel. So PQ and PR are parallel to each other, or they can be coinciding with each other. Okay, but in this case they can't coincide because their coordinates are different. So which means that they are parallel. So first, yeah. So first to find you just need to find the gradient of PQ and PR respectively, and given that they are equal, you just need to equate it and solve. Okay, so let's get started. So gradient PQ equals to, here's here for PQ, right, is -11 minus your y2. So -11, remember, minus then a bracket -9. So this actually becomes -11 plus 9. Okay, so if you simplify this, you get -2 over 6 minus k, or 2 over k minus 6. Okay. Then again, gradient PR equals to, Okay, so you get these two equations. So your next step is just to equate and solve. Okay, I won't be going through that part. Okay, again, this question I'll go through during our lesson time. So yeah, do attempt it before coming. Okay, I will go through the next segment as well. So the second part is okay, so given that now you know how to find the gradient. So if I give you 2 points in a straight line, another type of question that they can ask is to find the length of AB. Okay. So how would you find this length? So it's essentially your Pythagoras theorem concept. So let's take a look at it. So if you see, we have a right angle triangle. So let this point be C. So C is essentially, if you find out, your x coordinate of C should be the same as B, so it should be 7. And your y coordinate of C should be the same as A, so 7 comma 1. So if you calculate this distance, it's just the difference in your y coordinate, so it's just 9 minus 1, so it's 8 units. Okay? Then if you calculate your distance between A and C, it's just the difference in your x coordinate because your y is the same. So it's just 1 minus 7, so it's 6 units. 6 units. So your length of AB is essentially equals to square root of 8 square 8 square plus 6 square because this is a hypotenuse. Okay, so essentially this is the concept of the formula, but you realize how I had to um I calculated this 8 units and 6 units, right? So all this are actually depicted in one formula, and that formula would be line square root of x2 minus x1 square plus y2 minus y1 square. Okay, so again, it doesn't matter which one is y2, which one is y1, or x2 or x1. Just make sure that you can interchange it. Okay. So you see this formula, if we use this formula, we are gonna get the same answer. So let's see, x2 minus x1. So I let this be x2 comma y2, and then this one be x1 comma y1. So if I use this formula, it's just 7 minus 1 square plus um 9 minus 1 square. So again, I'll get the same thing, which is 6 square plus 8 square. Okay, same as the earlier one. So this is the concept behind this formula. Uh, yeah. Okay, so now let's try some practice. So do pause the video and try it out before I carry on. So just plug in the formula. You'll get 6 minus 4 square plus minus 5 minus 1 square. Okay, I won't go through the final answer, just plug it in the calculator. Okay, your next part. Okay, so this is slightly going to the application-based part of the question already. So, you're told to find the area of the triangle. Okay, so for this kind of question, I would prefer to draw it so that it's easier for me to see. Okay, so let's draw it out. You don't need to be accurate if you're drawing, it's just a rough sketch so that you know what's going on. So you have minus 3 comma 2. So let this be A and 1 comma minus 6. Maybe Okay. So find the coordinates of uh find the coordinate of point C that lies on the y-axis such that AC is equals to BC. Okay, so for this you gotta use your concept of line segment. So now let's take a look. So for example, let's say your point C lies over here, okay? Then they're saying that this length is the same as this length here. Okay? So let point C be x comma y. So again, now you have two equations to solve your two unknowns, which is x and y. So use the formula for line segment. So there will be square root of x minus 1 square plus y plus 6 square. So again, this equals to your other one, which is x plus 3 square plus y minus 2 square. Do you know that since it's minus 6, right? So y minus 6 would give you plus 6. So straight away I type in plus 6. Oh, sorry. Before we carry on, they said it lies on the y-axis. So that means your x is equals to 0. Okay? So straight away you can eliminate all the x. So you will get y plus 6. So you'll get y plus 6 square equals to y minus 2 square. Again, now you can get rid of the square root and square on the both sides because they cancel out. So you get y plus 6 equals to y minus 2. Okay, sorry, I made a minor mistake. So earlier we said that x is equals to 0, right? So you can't really cancel off x. So it still stays there, but just sub in as x is equals to 0. So in this case, it will be minus 1 square plus y plus 6 square. Square root is equals to 3 square plus y minus 2 square root. So you can square on both sides to get rid of the square root. So you get 1 plus, then you expand this, y square plus 6, 12y plus 36 equals to 9 plus y square minus 4y plus 4. Okay, so once you have this, again, just simplify the equation. So y square cancels off. And if I bring, so it gets 16y equals to minus 24. So I get y is equals to minus 1.5. Okay? So yeah, so that's how you get the answer. Then once you get this answer already, if you have time during exam, just double check by subbing into this equation and seeing whether they equate to each other. Okay? So now this part is done. Then the next part is find the area of ACO. So they want you to find the area of ACO. Yeah, so, to tackle this question, just treat it like a normal triangle. So you can use the formula half times base times height. So, if I let, so O is given to be 0, comma 0, and then this we found out to be, okay, so if you let your OC to be a base, then your height would be this portion. So this portion is your height, your vertical distance from A to your y-axis. So this is basically equals to, just you just need to look at your x coordinate. So it's just equals to 3 units because until here is minus 3, right? So if you just need to look at the modulus, the absolute value, okay? Then your this value is just equals to 1.5. Therefore, area triangle AOC is equals to half times 3 times 1.5. Note that your area can't be negative, so although your coordinates are negative, you don't need to show you're working in negative. Okay? Then you should get 2,104 units square. Okay? So yeah. Okay, I want you to try out these two questions. So do pause the video here and do pause the video here and try it out. I will go through the questions during your lesson time.